is the idle. Okay, so in this case, you can select the brute force way. This index is not so good to access such an inequality data. It's intuitively, it's an inequality. So you need to access most of the data. Okay, so then next one is DNO is equal to 5. That's different from the inequality. At that time, you can use the same option, but at this time it's different. Why? So D and O, this is here, 6. Because it's equality, you can access only that data. How many data? It's a selectivity, right? So this is index. Let's say we have the 4 departments. One index entry for each the block. 2, 3, 4. Each one will return how many? 80 tuple. So how many times do you guys need to access the table? 80 times. So 80 plus 11. Okay, that is 2 plus 80. So that is how much? 82. Which one is faster? It's using index, DNO index. So equality and equality will change even your table plot. Okay, query optimizer will use the different approach. Suggest a different approach. Okay. Then what about this one? This is the example of conjunctive. Conjunctive means it's a combination. So it has the DNO, it has the salary, it has the set. All of these each of them has index. So we can calculate the brute force is general. So we can consider, and using DNO we already did, and using salary is inequality. So we need to consider the half of all the data. And using sex, in this case, the return the 5,000 for each one time, but 5,000 tuple. So in this case, the DNO is equal to 5. Will be selected to determine the execution plan. Okay, like that. What if the join? The next one is a join. In case of join, what is a join? We have the two tables, R and S. Then we are going to find whether this row is matched. What is the match? Using join condition. That will be stored in the memory. That also require input and output. So that is called the join selectivity. Join selectivity means so total number of data. No, total number of Cartesian product combination. So it has the 10. This one has 20. How many combination? 200, right? For each 20. For each 20. Among them, we try to select the tuple that satisfies with join condition. That is called join selectivity. If you divide by this one, is a join selectivity. Okay. So this is a join selectivity, and the result 5. The after join is a join selectivity times R and S. Join selectivity is the ratio. So ratio times the R times S. We are going to use this one. This is join selectivity for each case. The first one is the nested roof join. Nested roof join is, what is a nested roof join? For each everything. For each everything. For each everything. For each everything means this time and this time. First, you need to access the left-hand side, our table, and this is a combination with the inner table, then join selectivity. How many of them are satisfied with the join condition? Then divide by blocking factor. Okay, so that is the nested roof. Similarly, single roof join is the use index, right? When you access, you don't search, you don't access all the inner table, S table. Instead, we can directly find that tuple using index. Okay? For example, secondary index, this is the cost of the secondary index. This is the cost of the cluster index. This is the cost of the primary index, and this is the cost of the hash. Okay? That's the only different thing. Instead of this one. Okay? This is a kind of brute force. This is an index, secondary index cost. This is a cluster index cost. This is a primary index cost. This is the hash key cost. Sort margin. It's very hard to define the pulse function. Why? Because first we need to sort the data. So if you have the cost of the sorting algorithm, you can calculate. Otherwise, it's very hard. So you can just understand sort margin. Need the first you need to access this one, then sort. So sort the cost function should be included. So this is an example. So from the previous one, it's the same thing. But in this case, we will add the department table also. How many department? 125 department. And how many block? 13 blocks. So you can calculate the blocking factor also for this. Okay. Then we have the more information about the department. That is the index. So D number. Only how many blocks in index? Only one block, one level index. Okay? And secondary index, we have the another index for the manager social security number. This one has the level is 2 and it's a unique. Okay? The selection cardinality is 1, that means unique. Level is 2. And join selectivity. If we join this table and employee table and the department table, how many? 1 over 125. Only 1 over 125 will be joined. Okay, that makes sense. Because on average it's 125 department for entire employees. So it's 1 over 125. And blocking factor of the join. The temporary table is the BFR. It is a 4. So 4 tuple for each join. So this is the example. This is like the select asterisk employee, comma department, and join. D NO is equal to D number. There is no other condition, selection condition. So we can consider only the join, the cost. So join cost. So as we have discussed before, accessing employee then department is different from department first, then employees, right? It's a different. So join into employee as an outer loop. That means this is outer loop. The left-hand side table is the first. Outer means the first. This is outer. Okay? Join with the department as outer. That is this one. So join with the employee as the outer loop, but this one, J2. J1 is for what? Nested loop. This one, single loop. In other words, nested loop join do not use the index. Secondary index, single loop join use index. So first, without using the index, what is the cost function? Cost function is this one. First, number of block of E. Next, the number of block times number of this block. This is the join, the Cartesian product cost. Cartesian product, then join selectivity. So that means, so number of block times the number of block of the department, and this is a join selectivity 1 over 125, number of record of the department, employee and department divided by the 4. This is a blocking factor for the join table. So then we can calculate 2,000 and 2,000 times 13 and 1 over 125,000, 10,000, 125. That is the number of this one. Then divided by 4. Then it has 30,500. Vice versa. So department first. So basically same thing. All of this, but only difference thing is who is the first. Okay? So you can see, depending on the order, the person may be different. So it has 28,000. What if the single loop join? In case of the roughly, intuitively, single loop join is faster than this one. Not always, but roughly, we can say. So how can you calculate the single loop join depending on what index you are going to use? So how can we determine? So you need to see what kind of index it has. There are two indexes. One is D number index, and another one is the manager social security number index. At this time, what index can be used? Can we use the manager social security number index? No, there is no manager social security number over here. In join condition, it is based on D number. So we can use the D number. Okay? So what is the cost? So number of employee, then D number. So 1,000 plus 1, okay? 2,000, and so let's see. Hourly, what is the hourly? It's 1,000, right? And XD number is 1. So 1 plus 1 is times 2, right? Then this is the same as the previous one. You can calculate. And that is the 24,500. IU. What if we put the department first? Then 13. Okay? First, then this is the we can use this time to access employee. We have the we have the index on employee. Employee DM. We can use this index, right? So using that index, we can calculate this one. 2 plus 80 is the selection cardinality times the number of block. Okay, then it's 12,763. Which one is the best one? What does that mean, best one?
Lowest cost.
Lowest cost. So this one will be selected. That means output is the this query optimizer will suggest first access the department, then join with the employee using what? Using index of the DNO in employee. It's a single loop join. Okay, that is the lowest cost. That's what you guys need to do in your project. So let me show the example. How can I? Change. Yes. So in your project, oops, what happened? Yes, I think there's something. Okay, so here, in your project 1, the first project 2, first page, you are going to implement the metadata catalog database for query optimizer. At that time, what kind of information do you need to implement your query optimizer? Table information. And
Number of blocks, block size.
that included in the table information, right? Index information. And the last one, join information. So first you are going to implement create the table for table information. So relation information. Table information doesn't matter, name. Okay? Then next one is the index information. So index the last one is a join information, join selectivity. And also for table information, we need the column attribute information, so that will be stored separately, that is attribute information. So for table you need to create table, attribute, index, and join. So for each table, in the table information we need, as he answered, we need a number of record for each table, record size, number of record, buffering fact, how many buffering factor for each table, and number of blocks used, okay, and so on. How can you get such information? In the project description. Oops, why? I can. Okay. Come on. One more time. Yes. So this is the project description. So you need to, the information that you need to create is already described. Okay? Table name. This is an attribute of this table. This one, this one, this one, this one. Then attribute info is the same. Index info and also join table. Then detailed information about each table is also given. So how many tuple? The 35,000 record, and for each is a 105 byte, and then is in case of the hash key, you can ignore. Okay, hash key don't pay attention to. Okay, implementing. I realized that implementing hash part is not easy to understand. Implementing itself is easy because you can just set up the one for hash key, but understanding hash key is not easy. So just ignore the hash part. The table is just a random access. So then secondary index and salary and the L name, and also each the distinct value is mentioned, and department also, and department location, and project work zone dependent. Okay, in this case, if you want to determine the size of record, then integer can be considered as a 4 byte. Okay, and other information you can follow the textbook. Otherwise, you can assume the size of the data. Okay, you can assume that. But that assumption should be mentioned. Like for example, if you want to consider the integer as of 8 byte, okay, so it's your assumption. It doesn't matter. It doesn't change a lot. But if you consider integer as 1K, 2K, so that doesn't make sense. Okay. So join info also created. So first up is based on this information, you need to create the 4 table and insert the data. What kind of data you need to calculate by yourself. Okay. So for example, relational info, table information data need how many tuples? 1 employee, 2 department, 3 department location, 4 project, 5 work zone, 6 dependent, 6 table, 6 record. Attribute information 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Count all the attribute, right? And index information, count the index for each table. How many index over here? The files all the cluster ESSN, cluster index ESN 1, 2, something like that. And primary key is always exists. So you can assume the primary key. Do not hash key, okay? The primary key. Then join information also here. Such details about the indexing structure we will cover next week. So while we are discussing about the index, you may realize such information. Then one more thing is after you create a table. So creating table is not a big deal once you understand. So you can create the SQL, create table, relational info, column. Then after you create it, you can insert the data. So you can submit the SQL for your submission. Then after you submit it, after we have the catalog table, like this is our catalog, relational info, attribute info, index info, join. So query optimizer need to access this data. Like whenever I explain, I back and forth, because our catalog information in the previous slide, right? Instead, back and forth, you are going to implement API program function to access the data. At least this one, whether table exists or not. If somebody types select from the Professor Lee table, it should be error, right? So at that time, you can use this function. Then get table information. You need to get the basic table information. How can you implement? Select asterisk from relational underbar info, where table name is you find from the query. This one. Then whenever you find the table, you can call the get table info. Department get table info using dynamic SQL that you learn in database program. It's just a simple function. Then get table attribute, table using the table name. Several attribute will be returned. The data will be returned. And has attribute at the return true or not. If this attribute name at the whether D and O exists in the employee one. D number exists either this one. If not, it's like the D11. It's not exist, it's error. You don't have to process it. So has attribute, has an index or not. You need to check whether this one is index one. This one is indexed one. Okay, using one, this table. So why don't you implement this function? Also, sometimes this is the minimum. You can use this one for your convenience. Once you implement one of them, the others are not very difficult. Believe me, really, why don't you try? Then, if you want a convenient way to access this one, you can make as many such a API as possible. That will simplify your phase 2. Phase 2, you can only focus on the function. Okay? Program languages. I give the JDBC as an example, but you don't have to. You can use any program language. The C#.NET also possible, and C program command line interface also doable. Okay, it doesn't matter. Any question?
Professor.
Yes.
Basically, we're gonna create those tables again.
The Oracle database that you have used.
Yeah, I mean, we're gonna create this information.
Yes, you need instance. Even you need to create your own.
Yes, the table that you described, so many tables employee.
Only
Do we need to create this actually?
Oh no, you don't have to create the actual table. Okay? You need only information. Okay? You don't have to create the real table. We are not going to use the SQL Plus to access the employee. No. You have your own interface. Okay? Do you understand what I'm saying? This is the not query through SQL Plus. Your query interface. So one of the examples is you can make a form like this, select from where and logical operator and another if there exists. That you can make your problem simpler. But you can use the command line. It's not very difficult.
But I have to access the database that I have first.
Yes, in your program, you should be able to access the data, not employee table, but this table. Yeah. Any other? Okay, so as I said, for undergraduate student, it's optional, it's extra work, but for graduate student, it's mandatory 3, group by 3. So you can form a group by 3.
I guess, yes.
Which one do you prefer? It's the same team as the first project? Yes, same team as the first project. Okay? Any others? Okay, thank you. And See you next week.